Okay, so your question was, you thought carbon fiber didn't flex, just took the stress with little strain and then failed. Why not just use fiberglass if you want flex? So let's have a look about that. So first of all, what we need is this graph, which is strain here, and here is deformation there. So if I take aluminium, for example, the curve will be something like that. Okay, then here, failure. If I take carbon fiber, it will be like, it's stiffer, so it's like that. It can endure more strain, but then fail without what we call plasticity. So this part here is plasticity. You can see the curve is like that. So here elasticity, here plasticity. So now if we take glass fiber, it will be something like maybe like that. Okay, or maybe even more like that, I don't know. But it's like straight and then failure. So if we look about that, both of them can under strain. Carbon fiber can support much more strain than glass fiber because it's like that, it's more resistant. Sorry for my English, it's been a long time I didn't speak in English, so I'm not that good and my accent is very poor. So just took the stress with little strain. That's absolutely false. When you have a deformation, you see here, for the same deformation, as a strain, if I go the path that way, on the carbon fiber is much more higher than in glass fiber. For example, for the same glass fiber, we do have a strain that is lower. And that's the point. That's the strain that breaks a material. It's not the deformation. So now, what we can see with that is if we use glass fiber and carbon fiber, glass fiber will be more suitable for flexibility. Because if we have a plate like that, and we make it bend, like that, up, you can see here we do have elongation. Here is the neutral fiber, which has no elongation. Here we do have compression. In the inner part we have compression. In the outer part we have elongation. And here this is neutral, so no elongation, no deformation. So if I do have a material that is very thin, even if it's carbon fiber, glass fiber, or whatever, it will not break. If I took like a very thin, and I can make that without any problem. But the fact is, if I zoom in, it will have this look, and here we will have elongation. And so that means elongation here, I go there, up, and elongation equal strain. So if I have, if I do have a given thickness here, let's call it E, for the same thickness, I will have higher strain on carbon fiber than glass fiber. But if I do have a material that is quite thin, I can have flexibility on carbon fiber. And the way to do that is to take this graph and go the other way around. I can say, okay, I want to have this kind of strain, so that I do have like this amount of security factor, you know, and here I go that way, and okay, I can have this amount of elongation, and that means elongation. I can calculate the elongation on the outer fiber of my material, and so that I can say we can have, let's say, 30 centimeters of radius. Damn it. I hope it's gonna be understandable. It's like very, it's not that clear, but hope you can understand that. Let me tell if you want more explanation.